Okay, these are the notes for Monday, September 14th. I'm just going to review some typical type of radical problems, and then you guys are going to do a quizzes assignment. I'll open it up here in a couple of minutes. And again, just get as much practice as you can. You guys will have a quiz on Thursday, but I just want to cover all the different types of multiplying problems with radicals. So if you look at this first problem, it's just a radical 6 and then in parentheses a radical 12. So we're going to multiply these two. Well, 6 times 12 is 72, so a radical 6 and a radical 12, the answer is going to be the square root of 72, unless we can simplify that. Now, again, you could break that down into 8 times 9, 36 and 2, whatever you want to use, 24 and 3, you can use your calculator on all that. I'm going to use 36 and 2. And again, why am I using 36 and 2? I know with 36, I get a pair of 6s. So we have a pair of 6s. 6 goes on the outside, single 2 on the inside. There's my answer right there. All right? Now, the second example, just like the first one, except I have numbers outside the radical. Remember, when we multiply, so this is 5 radical 2 and then parentheses, so we're going to multiply by 6 radical 10. So I'm going to multiply outside numbers by outside numbers. Okay, 5 times 6 is 30. Then I'm going to do inside times inside, but that's going to be a radical. So 2 times 10 is 20, so a radical 2 times a radical 10 is a radical 20. There's my answer, unless I can simplify it. Well, we can break down 20. 2 and 10, 4 and 5, it doesn't matter. I'm going to use 4 and 5 because I know I get a pair of 2's. So 2 joins the 30 on the outside. So 2 times 30 is 60. Where does the single 5 go? On the inside. So it's 60 radical 5. All right? Example 3, very similar to number 2, except now you have some exponents inside the radicals. Rules don't change. So we're going to multiply outside by outside. So that's 24, 6 times 4. But then we're going to multiply everything inside the radicals. So 3 times 6 is 18. But again, remember your exponent rules. What is x to the third times x to the fourth? If the base is the same, we add the exponent, so it's x to the 7th. That's your answer unless you can simplify it. So let's look at the number first. Can we break down 18? Sure. 9 and 2. 2 is prime. 9 gives you a pair of 3's. It's a perfect square. So who does 3 join? Joins the 24. So we're going to have 24 on the outside times 3 on the outside. I'm going to leave a little bit of space. Where does the 2 go? On the inside. Now, don't forget, you had 7 x's. You can write the letter x 7 times, but how many pairs can you get out of 7? You can get 3 pairs, because that gets you up to 6. But then where does the single x have to go? Back in the house. Now there's your answer, except you can do better than 24 times 3. What is 24 times 3? 72. So it's 72 x to the third radical 2x. Alright? Now, what if we have 3 radical 2x on the outside, but then we have a binomial? Radical 5 radical 6x plus radical 5x to the fourth. Now we have to use distributive property. So again, we're going to multiply this by the first thing. But outside numbers get multiplied by outside numbers. So the 3 and the 5 get multiplied together, so that's 15. Now we do what's inside the radical times what's inside the radical. So radical 2x and a radical 6x should be radical 12x squared. We'll come back and simplify that in a minute. Okay, I got a plus sign here, so plus. Now I'm going to multiply this. It's just distributive property. So the 3 gets multiplied by the 1 that's here, so that's 3. Then we multiply what's on the inside. So that's a radical 2x times a radical 5x to the fourth. Well, 2 times 5 is 10. What's x times x to the fourth? Remember, add the exponents. That's x to the fifth. There's your answer, unless you can simplify it. I think we can simplify 12. 4 and 3. 2 and 2. Okay, 3 is prime. So 2 joins the 15. So 2 times 15 is 30. Leave a little space because I see an x squared. The single 3 goes inside. Don't forget, you had an x squared here. That's a perfect pair, so x on the outside. So that takes care of the first one. Bring down the plus sign. Can you break down 10? Now you can get 2 and 5, but no pairs. But what about this x to the 5th? How many pairs can you get out of that? All right, you should be able to get 2 pairs. So you had a 3 on the outside, 2 pairs of x's. But remember, if there were 5 x's, it's an odd number, you're always going to have 1 left over. You had 2 pairs, but a single one left over. So the 10 was still inside, and a single x. That's the best you can do. Radical 3's don't hang out with radical 10x's, so the best you can do is that right there. There's your answer there. All right. What if it is binomial times binomial? Then you have to use FOIL. Okay, no problem. 3 times a radical 2. That is a regular 3. So the best you can do is 3 radical 2. That's first. Let's do outside. 3 times a 4 radical 6. The only numbers that can be multiplied are the 3 and the 4. So 3 times 4 is 12 radical 6. All right, let's do inside. That's a negative radical 6 and a radical 2. That's a minus or a negative radical 12. You can simplify that one later. And let's look at the last one. Remember, that's a negative 1 right there times a 4. So that should be negative 4. But what's radical 6 times radical 6? It's radical 36. It's going to turn right back into 6. So let's see if we can't simplify this thing down a little bit. Okay. You cannot simplify him. Can't simplify him. But you can break down 12 into 4 and 3. Why do we like 4? 2 and 2. Don't forget the 2 joins a negative 1 here. So this is really minus 2, single 3, radical 3. And again, 36 is just a perfect square. It's a pair of 6's. So who does the 6 join? The minus 4. So 6 times negative 4 is minus 24. You didn't touch this, so bring it down. And you didn't touch this, so bring it down. Bring down this plus sign. Now, any radicals go together, a radical 2, a radical 6, a radical 3? Nope. That's the best you can do. Sometimes they can go together, sometimes they can't. In this case, nothing went together. There's your simplified answer. All right, last one. Should notice something about this. Yes, it's FOIL, but it's difference of squares. Remember the shortcut. If you see same terms but different signs, that's difference of squares. You can take out outside and inside. You only need to multiply first and last. 7 times 7, that is regular 7 and a regular 7. That's not the square root of 49, that's just 49. Do last times last. Radical 5 minus radical 5, so that's a radical 5 times a negative radical 5. That's negative square root of 25. But remember, if it's same radical times same radical, it's always a perfect square. Square root of 25 is 5. So this is really 49 minus 5. What's a better way to say 49 minus 5? Should be 44. And that's the best you can do on that one. Alright? Alright, go back, check. I'll have the quizzes code posted. Make sure you guys do that. It'll tell you how many you need to do to get full credit on it. And if you got any questions, don't forget you can email me or sign up for the tutoring on Wednesday. Alright, thanks.